Hi everyone, so now we will start the assignment. So this might be the last or second last video of our this transmission line. Now there will be a lot of guys who will be coming just for the sake of the problems, because there would be some guys who have studied this particular topic from somewhere else, and now they are thinking that they can solve the problems. So if you are just coming for the sake of problems, then I would highly recommend to watch the conceptual videos as well, because in the conceptual video we have solved a lot of problems. Okay, so I highly recommend to watch those videos as well, because there also you will find something new, a new concept also you can find, and new problems also you can find. And if you are someone who is watching this playlist right from the beginning, then certainly this is just a new video for you, and you can start solving these problems. So first I will show the questions. This is the first one. Second, this is the third one. When we were studying scattering parameters, I told you that I will deal this question in assignment. So we need to find the scattering parameter of an ideal transformer. And then this is the question, Jadin you need to find. And then this question, then this one you can read. This is very easy one, this is not tough. Then these patterns, this problem, and then this question, this is based on transients. Then this one, number of voltage maxima. Then this is on S matrix, and this is also based on scattering parameters. Okay, so these questions we are going to solve. So let's start from the first one. So this you need to mark the correct statement. So I think you should be able to solve this one if you have studied Smith chart. So the centers of constant R circle lie on the line which is tangent to the constant X circle. So where will be the centers of constant R circle? The centers of constant R circle. So if you remember, one center was at 0, 0, then one was at 1 by 2, 0, 1 by 3, 0, 2 by 3, 0. So always the center will be lying on something, 0. That means centers will always be lying on gamma real axis, right? Or we call it U. So these are the centers of constant R circles. Now what they are saying, the center of constant R circle lie on the line which is tangent to constant X circles. So where are constant X circles? Let's just say this point is 1, 0, assuming this point is 1, 0. So constant X circle will be somewhere here. So these are constant X circles. So what is the common tangent to all the constant X circles? This we have already seen, this line only. So yeah, this statement is correct. That the center of constant R circles are lying on the axis which is tangential to all the constant X circles. Okay, so this was the first statement, which is absolutely correct. So first one absolutely correct. What about the second one? The center of all the constant X circle lie on the line which is tangent to constant R circle. Okay, so where will be constant R circle? Let's just say if this is 1, 0. So from 1, 0 circles will be originated. So these will be your constant R circles. All will be passing through 1, 0. So what will be the tangent? This will be the tangent. Now on this tangent only all the centers of constant X circle lies. Why is that so? Because how does the constant X circle goes? Constant X circle goes like this, like this, like this. So here only there was the centers. Like if you remember, the centers were at 1, 1, 1, 1 by 2, 1, and here also there could be centers. So it was at 1, minus 1. So all the centers will be lying on this particular line which is tangential to our constant R circles. So these kind of concept we have already seen. So second statement is also true. And in the last video only I told you that both of them are the family of orthogonal circles. That constant X circles and constant R circles forms a family of mutually orthogonal circles. Or you can say all of them are true. So these four statements are true. So these kind of questions can be asked, like they will write the statement and they will ask whether it is true or not. Let's see the second one. Clockwise movement on constant R circle leads to the X value increasing. So what you will do is that clockwise movement on constant R circle. So any constant R circle you can make. I am making for R equals to 0. This circle I am making for R equals to 0. Okay. Certainly this will be passing through 1, 0. Now here there can be many of your constant X circles like this, like this, and like this as well, like this as well. What they are saying, this would be coming for X equals to 1. What this would be coming? X equals to 2, because as the X value increases, the radius decreases. Now what they are saying, if you are moving clockwise movement on constant R circles, clockwise movement means like this. So if you are moving on constant R circle clockwise, then x value is increasing. Yes, x value is increasing. But here this is x equals to minus 2, no? And this is x equals to minus 1. If I am moving clockwise, so here x value is decreasing, no? Right? If you are moving clockwise here, the x value is decreasing here. So leads to positive x value increasing, okay? Positive x value increasing, and here I am writing negative x value decreasing. So here it should be positive x value increasing and negative x value decreasing. That means if I am moving clockwise on constant r circles, then x value is increasing, yes, but positive x value, and negative x value is decreasing. Negative x value is decreasing from minus 2 to minus 1 you are going. So this value is decreasing, but in negative direction it is decreasing, right? Which is greater? Minus 1 is greater, but I am saying that from minus 2 to minus 1 you are going, that means it is decreasing. That means in negative direction it is decreasing, no? So clockwise movement on constant r circle leads to the negative x value decreasing. So negative x value, that means initially I was having minus 3, now I am having minus 2. So this decreased, negative x decreased, okay? So this is what we are saying. Now what next they are asking? Clockwise movement on constant x circles leads to the r value decreasing. So let's make some constant x circle. This could be your one of your constant x circles, and certainly this could also be one of your constant x circles. All will be originated from 1 comma 0 only, okay? And this would be my some r circle. So better use different color of pen. So let's make some r circles. So this is my one of the r circles. This which r circle is that? R equals to 0. Other r circle also I can make. Let's make this r circle. Which r circle is that? This could be something else. R equals to 0.5 it could be. This is r equals to 0 for sure. This is r equals to, it could be some 0.5. And this is for sure, this is equals to x equals to 1, and for sure this is x equals to minus 1. What they are saying? Clockwise movement on constant x circle. Clockwise movement. Here we are moving clockwise. So clockwise movement on constant x circles will result in decreasing value of r. Why is that so? Because here r was 0.5, now r has become 0. So 0.5 to 0 you are going, 0.5 to 0. So r value decreasing. But this is happening on positive x circles, no? This is happening on positive x circles. Okay. And this statement doesn't look clear. Really sorry for these errors. Okay. Here only I am noticing it. Now clockwise movement on constant x circle. So this is also a constant x circle only. No? Here also you can do clockwise movement. This could also be a clockwise movement. No? So here r value was 0. Now r value has become 0.5. So r value is increasing here now. So r value here was 0. Here r value has become 0.5. So r value is increasing if we are moving clockwise on constant x circle, but constant negative x circle. Okay, constant. If you are moving on constant negative x circle, then r value is increasing. So you just need to draw the diagram, and there you will get to know that here r value was 0, 0.5. So on negative x circle, if I am moving, so r value is increasing. So r value is increasing. So A, B, C, D all are correct. Okay. Now you need to find scattering parameter. So I have told you the method. What we are going to do? We are going to introduce. We will take this diagram, and then we are going to introduce some transmission line of impedance Z naught. That impedance will be mentioned actually in the examination, but here it is not mentioned because you will understand that the impedance will not come into action. But you need to know a few things about transformer. I hope you know it. We will check if you know it or not. So what we do? V1 plus is incident, V1 minus is reflected back. Here we assume V1 plus V1 potential. Now here V2 plus is incident and V2 minus is reflected back, and here we assume V2 impedance. Okay. Now then what we do, our first task will always be to define the parameters. So this will be the definition. Here only there will be simple mathematics, nothing else. S21 V1 plus S22 V2 plus. Okay. Now they haven't given the Z naught value, so I am assuming these Z naught values. These could be different as well, but later on you will get to know that these are of no use. Okay. Now what I need to find? I need to find S11 and S21. So my first target is S11 and S21. So if I need to find these two parameters, then what I'm gonna do? For that, what I need to do? I need to put V2 plus equals to 0. So what is V2 plus? V2 plus is acting as a reflected wave for this particular load. Okay. So let's not make this diagram bad. What I'm gonna do? I'm gonna just copy this diagram here. And here what I need to do is that I need to keep V2 plus equals to 0. So here it is acting as a reflected wave. So I will use the matched load. If I have used the matched load, then what will be the input impedance from here? Z0, Z0. So it will always be Z0 only. So I can remove it off. What do I get to know is that now the equivalent impedance I get here is Z0. Okay. Is that clear to you? Now there is one more relation. What is that? V1 by V2 is equals to N1 by N2. This is coming from transformer, property of transformer. Okay. This is the property of transformer, that this voltage divided by this voltage is equals to this turns divided by this turn. Okay. Property of transformer. How do we write it? Transformer. Okay. Transformer. You will understand. So this is the property. Now one more thing we can do, if you know it. If you need to take this impedance Z0 towards the V1 plus side, then how will you take it? If you need to take this Z0 impedance towards the V1 plus side, then how will you take it? Electrical student knows it, but as a EC student, you should also know it. Okay. So if you want to take this thing, then what you need to do is that you need to refer it towards the input side. So that impedance will also be some impedance Z0 only, but it will be multiplied with the factor of N1 by N2 square. Okay, from here to here it is going. So N1 by N2 square. Z0 into N1 by N2 square. So where finally it is going towards N1. So N1 by N2 square. Is that clear to you? So this will be your Z0. This will be the impedance. Now here this is having Z0 impedance and this is the load impedance. So if you need to find V1 minus, this was your V1 plus. So if you need to find V1 minus divided by V1 plus, that is equals to your S11 only. But this condition is coming when I have kept V2 plus is equals to 0. So that will be equals to S11 only. What that would be equals to ZL minus Z0. ZL minus Z0 upon ZL plus Z0. ZL plus Z0. So if you solve it up, what you are getting? We are getting N1 square minus N2 square divided by N1 square plus N2 square. No need to mug it up. Okay. In the examination, you will be able to solve it very quickly. Well and good. Now from here, what do I know? V1 is equals to N1 by N2. V1 is equals to N1 by N2 into V2. What V1 is equals to? V1 is having both of the components. But as of now, what we have done is that we have made V2 plus is equals to 0. And now what we need to find? We need to find S21. What we need to find? We need to find S21. So what S21 will be equals to? S21 will be equals to V2 minus divided by V1 plus, considering that your V2 plus is equals to 0. So what I need to get? Divided by V1 plus. So what I am going to do? I will divide by V1 plus on both of the side. If I divide by V1 plus on both of the sides, so this is what I am getting. Right? So this is simply 1 plus, what is the value of V1 minus divided by V1 plus? That is equals to N1 square minus N2 square divided by N1 square plus N2 square is equals to N1 by N2 into S21. So from here S21, what you are getting? So this will be 2N1 N2. S21 we are getting is 2N1 N2 upon N1 square plus N2 square. So this is your S21. Okay. Now third task. What I need to find now? S22 and S12. So for that, what I'm gonna do? So now I'm not gonna make the complete diagram. What I'm gonna do is that I'm gonna replace this with Z0 because I need V1 plus equals to 0. If I need V1 plus equals to 0, so that is acting as a reflected wave only. So if I need V1 plus equals to 0, so that I will replace this with Z0. Now what will be the input impedance? Input impedance will be equals to Z0 only. Input impedance will be equals to Z0. Now that Z0 will be referred, this Z0 will be referred to this side. So how it will become? Ditto the same circuit will become, right? It will become ditto the same circuit. Just Z0 value will be different. What will be the Z0 value now? Basically, the Z naught will be referred to the input side, and now here we are having the transmission line. This is the transmission line we are having. Okay, on this transmission line, V2 plus is incident. This V2 plus is incident, and V2 minus is being reflected back. What will be the value of this impedance? This impedance will be Z naught into N2 by N1 whole square. Why is there so? Because from here Z naught is being referred to this side. All these concepts would be clear if you are good enough with this concept. So now this is Z naught. So now if I need to find my V2 minus divided by V2 plus, but that is coming considering that V1 plus is equals to 0, and that would be equals to S22. So that would be equals to ZL minus Z naught. Here what formula? Yeah, okay. ZL minus Z naught upon ZL plus Z naught. Okay, so what you are getting, S22 equals to, again add the page. So this is just mathematics, nothing else. So S22 is equals to N2 square minus N1 square divided by N2 square plus N1 square. Okay, and what else we know? Now what I need to find? I need to find S12, which is equals to V1 minus divided by V2 plus, considering V1 plus is equals to 0. So what do I know? V1 is equals to N1 by N2 is equals to V2. So better I should write V2 is equals to N2 by N1 V1, right? What is V2? In V2 you are having both V2 plus as well and V2 minus as well. But in V1 you are already only having V1 minus, because V1 plus has been kept to 0. Now what you are going to do? You are going to divide by V2 minus. So if you are going to divide, no, sorry, you are going to divide by V2 plus. So if you divide by V2 plus, so this will be 1. V2 minus divided by V2 plus, V2 minus divided by V2 plus. What that would be? That would be this quantity, that is S22 only. That would be equals to S22 N2 by N1. What will be V1 minus divided by V2 plus? That would be S21. Okay. So if you add 1 here, what you are going to get is that from here I can see that S21 will be, if I add this 1 here, so 2N1 square then N1 by N2. Yeah. So I am getting 2N1 N2 upon N1 square plus N2 square. So what kind of parameters you are getting? So what is your S matrix? So first you are having here S11, which was N1 square minus N2 square divided by N1 square plus N2 square. Now here you are having 2N1 N2 upon N1 square plus N2 square. Here also S21 is 2N1 N2 upon N1 square plus N2 square. And what about this one? This was your N2 square minus N1 square divided by N1 square plus N2 square. There you go. This is your matrix. Okay. That final. Okay. So this is the matrix. Very easy thing. So this we have found out. One time, like in GATE 2020, I guess one question was asked on this concept. Okay. Let's see the next one. What you need to find? You need to find Z in. What do we see here? Length is lambda by 2. So here what I can see is that Z in is equals to ZL here. Why is that so? Because length is lambda by 2. So what is my target? My target is to find ZL only. What is given? Load impedance is, sorry, reflection coefficient is given at load. What is that? 0.5 e to the power. First write down the definition only. This question I just took for the calculation purpose, nothing else. So gamma L is there. That will be equals to ZL minus Z naught upon ZL plus Z naught. Z naught value is real. So I can put it very comfortably. Now my gamma L value is complex. So whenever these kind of calculations are coming in front of you, so what I need to find? I need to find ZL. So what my target would be that I will take ZL on left hand side and rest of the things will be on right hand side. Because I don't want to do the complex calculation. Here I am not putting the value of gamma L. Why is that so? Because gamma L is complex. Then it would make my calculations a bit tougher. So what my target would be that I take ZL this side and rest of the things other side. So gamma L is equals to ZL minus 50 upon ZL plus 50. So from here I can see is that gamma L ZL plus gamma L 50 is equals to ZL minus 50. So what is my target? My target is to take ZL on this side. So ZL is equals to gamma L minus 1 is equals to 50 into gamma L plus 1 here, but minus sign is outward. So ZL is equals to 50 into 1 plus gamma L upon 1 minus gamma L. This is what you are getting. So simple mathematics you need to do. I will just check the calculation if I have done it correctly or not. So ZL is becoming common, gamma L minus 1, and then this goes here. So this would also be negative, gamma L plus 1, the negative sign minus 50 is there. So that 1 minus gamma L. Yeah. So this is your ZL is becoming now. Now I will put the values. So what is my gamma L? Gamma L is 0.5 e to the power j 53 degree. So 0.5 cos 53 minus j 0.5 sin 53. I hope you know how did I put the minus sign there. So what is 53? 53 cos 53 is 3 by 5. So this will be 0.3 minus j. This is 4 by 5. So that would be 0.j. Sin 53 is 4 by 5 only because 37 is 3 by 5. Yeah. So this is 4 by 5. So this is the calculation. So ZL is equals to 50 into 1 plus 0.3 minus 0.4 divided by 1 minus 0.3 plus j.4. Minus 0.3 plus j.4. So 50 into 1.3 minus j.4 divided by 0.7 plus j.4. Now we need to solve this calculation. Okay. So I will use the calculator. You also do the calculator. Now the calculation has become pretty easier, like easier than what would have done, what we could have got when we put the values directly. So that's why I took this question. Like it was an easy question only, but the calculation part was the more interesting one. So 1.3 whole square plus 0.4 whole square. (1.3 whole square plus 0.4 whole square). (1.36). Okay, I will pause the video and do the calculation. So ZL is coming out to be 85 and magnitude is 85 and the angle is minus 46.85. So it is a capacitive load. Okay. So just this calculation was required. A transmission line having characteristic impedance Z0 is cut into two halves of equal length. The characteristic impedance of each length is. What do you think? What will be the answer? What is your Z0? For any line, that is R plus j omega L divided by G plus j omega C. Is it depending on length? No. This is a transmission line having Z0 characteristic impedance. If I cut it in half, then two lines will be there. Both will be of Z0 impedance only. It doesn't depend on the length, right? So answer will be Z0 only. So both of the lines would be having Z0 impedance only, right? Wait a minute. Okay. Now try solving this question. It is an easy question. Just the language is tough. Like a language is bigger, not tougher. Language is bigger. Otherwise, it is easy. You can solve it. So a transmission line having a characteristic impedance of 200 ohm is terminated with the load impedance of ZL. Okay. If the load is replaced, now the load is replaced with a short circuit, then the maxima position is shifted lambda by 4 away towards the source side from the previous value. So what do I mean by that? That if you replace the transmission line with short circuit, then what will be your location of maxima? You let me know. That would be lambda by 4 at lambda by 4 only. No? If ZL is equals to 0. If ZL is equals to 0, then what is the gamma L? Gamma L is minus 1. So where will be your maxima? Where will be your maxima? At y equals to 0, you will get minima. At y equals to 0, you will get minima. And at lambda by 4, you get maxima. So here you get maxima. Right? This is the scene when ZL is equals to short circuited. So what they are saying, that the maxima position is shifted lambda by 4 away towards the source side from the previous value. That means previously the maxima we were getting at y equals to 0. If this is if this is my y is the distance from load. So previously I was getting my maxima at y equals to 0. When ZL is equals to ZL, when ZL was there, then maxima was at y equals to 0. How did I understand that point? How do I conclude that my maxima was at y equals to 0? Because the language is written that if the load is replaced with short circuit, then your maxima position is shifted lambda by 4 away. That means previously if it was at x, now it has, if let's just say I call this as x, now it has become at x plus lambda by 4. So it has been shifted lambda by 4. That means previously it was lambda by 4 back. And if you subtract lambda by 4 from here, what do you get? At 0 only. So previously your maxima was at y equals to 0. So previously I was getting maxima at y equals to 0. Okay. And what else information they are giving? When the line was terminated with ZL, the VSWR on the line was 4. Find the magnitude of ZL. So VSWR value was 4. When it was terminated, when the line was terminated with ZL, when the line was terminated with ZL, at that time VSWR was 4. Now at y equals to 0, you are getting some maxima or minima. In this case, you are getting maxima. So at y equals to 0, if you are getting maxima, that means certainly it has to be resistive load, because in case of inductive load, in case of capacitive load, or in case of complex load, at y equals to 0, you do not get anything conclusive. So it has to be resistive load, right? Now that resistive load would be greater than Z0 or less than Z0. At y equals to 0, if you are getting maxima, that means resistive load has to be greater than Z0. That means ZL has to be greater than Z0. If ZL is greater than Z0, then what will be the formula of ZL? That would be S into Z0. What is the value of S? S is 4 and Z0 is 200. So ZL is equals to 800. That's it. Here I can solve it. What I mean to say is that first I saw the short circuit one, then I go to know that my maxima will be at lambda by 4. They are saying that it is shifted lambda by 4. That means in the previous state your maxima was at Z equals to 0. Sorry, y equals to 0. My maxima was at y equals to 0. Now at 0 I am getting some maxima. So there could be 3 possible states, that either it could be resistive, or it could be short circuit, or it could be open circuit. If it was open circuit or short circuit, then VSWR would have been infinity. But VSWR is some finite number. That means VSWR is some finite, so load has to be resistive. Now if the load is resistive, then either it could be ZL greater than Z0 or ZL less than Z0. If it was ZL less than Z0, that means at y equals to 0, I was getting my, if ZL was less than Z0, so I was getting my minima. And if ZL is greater than Z0, then I would have got maxima. So what I am getting maxima only. So ZL is greater than Z0. So what is the value of ZL? ZL is S into Z0. What is the value of S? S is 4. And what is Z0? 200. So ZL is 800 ohm. There you go. And it is resistive as well. That also we have concluded. So kind of summary of what do we call that? Kind of summary we have seen for standing wave pattern, right? Let's see this question. This is a very interesting one. So load is capacitive, complex capacitive. Load is complex capacitive. So which of the following option is the correct current standing wave pattern? Okay, current standing wave pattern. So those who do not study Smith chart, what they will say, that sir, since the load is capacitive, so current maxima will occur first. Here also current maxima is occurring first. Here also current maxima is occurring first, and here also current maxima is occurring first. Here minima is occurring first, so this is wrong. So all three options A, B, C are correct. That answer is wrong. Okay, A, B, C, all three are not correct. Why is that so? Because what did I tell you? You need to see the length. What is this length? This length D. This length D. This length D is greater than lambda by 8. What about this length? This length D is equals to lambda by 8. And here D is less than lambda by 8. Now you need to draw the Smith chart and you need to understand whether the length will be equals to lambda by 8, greater than lambda by 8, or less than lambda by 8. So what we are going to do? We need to see our ZL. And what is our interesting impedance? That is 50 ohm. So what will be my ZL dash? ZL dash will be 100 minus J50, 100 minus J50 divided by 50. So that would be equals to 2 minus J. Okay, so now which circles I need to make? What is the value of R? R is equals to 2 and X equals to minus 1. So all the circles will pass from 1 comma 0 that I already know. This will pass from 1 comma 0 only, and this is my U, this is my IV. Okay, now Now for constant reactance circle, if I draw the constant reactance circle, then it would be going something like this. Why is that so? Because this is the circle for x equals to -1, which I already know. Now what about r equals to 2? Do I remember the circle of r equals to 1? This is the circle of r equals to 1. This passes through this circle passes through this imaginary axis. So now where will be your r equals to 2 circle? So r equals to 2 circle will be somewhere like this, right? Why it is like this? Because as the value of r increases, the radius decreases. So for r equals to 0, this was the circle. For r equals to 1, this was the circle. Now r equals to 2, this would be the circle, right? So this is the circle for r equals to 2. So where it is cutting? Here it is cutting. Can I draw the constant VSWR circle now? Yes. What I need to do? I need to join this line to the origin. Now taking this as a radius, I need to draw the circle. So taking this as a radius, I need to draw the circle. So this is how it will look like. Okay. So this is my constant VSWR circle. All these concepts we have studied when we were studying our Smith chart. Okay. Now in which direction I will move? I will move on clockwise direction because I am moving towards the load. So I am moving towards the source. So in which direction I will move? I will move in clockwise direction. What will be the clockwise direction? This will be the clockwise direction. So this is my y equals to 0. Now if I move in the clockwise direction, what do I get first? This is the location of V minima, or you can say I maxima. So first I will get I maxima. So certainly I will get first I maxima. But how much angle I need to cover? This much angle I need to cover. So this angle is certainly greater than 90 degree. So the angle that you need to cover is certainly greater than 90 degree. If I talk about this theta, so this theta is certainly greater than 90 degree. That means the D has to be greater than lambda by 8. There you go. Okay. So D has to be greater than lambda by 8. So to get to the I maxima, you need to cover more than lambda by 8 distance. So this will be the correct one. This will be wrong. This will also be wrong, and certainly this is wrong only. Is that clear to you? Fine. So those who have studied Smith chart, I have spent roughly around 30 to not 30 to 35 minutes. I guess I spent around 1 hour in discussing only this thing. So certainly these kind of questions are coming in future. Okay. Okay. Now let's see this question. You need to find the value of L, Vg and Zg. Okay. Short circuit line is there. You need to find the value of L, Vg and Zg. What is L? L is the length of transmission line. Vg is the generator voltage, and Zg is this impedance. And this is the bounce diagram, not bounce diagram. This is the waveform is given at y equals to 0. That means at source and potentials are given. So what is this 12 volt? Just as you close the switch. So what will be generated here? V0 plus. Now that V0 plus will be traveling. How much time it will take? It will take t time. Then at t time what will happen? Gamma L V0 plus will be coming here. So at 2t time gamma L V0 plus will be reaching here. At which time? At 2t time. And at 2t time only another waveform will be generated, that is gamma L gamma G V0 plus. So from these things what I can conclude is that my V0 plus is equals to, here in this particular video, in assignment video, I am moving a bit faster. Why is that so? Because we have seen the concept, that's why we are moving faster. Otherwise when we were seeing the concept, we were studying very slowly. But now the concepts are clear. So V0 plus is equals to 12 volt. Now V0 plus gamma L V0 plus gamma L gamma G V0 plus, that is equals to 3 volt, right? That is equals to 3 volt. Okay. Now what is the value of gamma L? Gamma L is ZL minus Z0 upon ZL plus Z0. What is the value of ZL? ZL is short circuited. So ZL is 0. So what is the value of gamma L? Minus 1. So gamma L value already I know, that is minus 1. Okay. Gamma L is minus 1. So V0 plus minus V0 plus, and this is minus 1 gamma G V0 plus is equals to 3 volt. So V0 plus is 12 volt. So from here what do I get to know is that minus gamma G V0 plus is 12 volt is equals to 3 volt. Minus sign is there. So gamma G is equals to minus 1 by 4. So what you are getting, gamma G is equals to minus 1 by 4. Is that they asked? No, they did not ask the value of gamma G. They asked the value of Zg. So what is gamma G? Gamma G is Zg minus Z0 upon Zg plus Z0. That is equals to minus 1 by 4. What is the value of Z0? Z0 is given as 50 ohm. So Zg minus 50 into 4 is equals to minus Zg minus 50. So 4Zg minus 200 is equals to minus Zg minus 50. So 5Zg is equals to 150. So Zg is equals to 30 ohm. There you go. Rest you can recheck as well. 30 minus 50 is minus 20. 30 plus 50 is minus 80. So yeah, minus 1 by 4 only we are getting. So this is the calculation. Very easy thing. Okay. Very easily we are doing the calculation and we are finding out these values. Well and good. So Zg value we have found. What else we need to find? We need to find the value of Vg. Now can I find the value of Vg? Certainly I can find out. Why is that so? Because at t equals to 0 plus, what my V0 plus will see? My V0 plus will only see Z0. So at t equals to 0 plus, I can replace my circuit as this is my Zg and this is my Z0. So this is my Vg. What is my Zg? 30 ohm. What is my Z0? 50 ohm. And what will be this potential? This potential will be equals to V0 plus. So my V0 plus is equals to 50 divided by 80 into Vg, right? And what is the value of V0 plus? V0 plus is equals to 12. V0 plus is equals to 12. So 12 into 8 by 5 is equals to Vg. So Vg value I am getting, which is very easy only, 12 into 8 by 5, 19.2 volt. 19.2 volt. Let's check back the calculation. So V0 plus 50 by 80 into Vg, 8 by 5 will be going there, and V0 plus was 12 volt only, so 12 into 8 divided by 5. Okay. So Vg is 19.2 volt. So this we have found out. Now what is this value? 7 microsecond. What do you think? What is this value? This value is 2t time, because at 2t time you are having 3 volt, right? Because t will be taken to go here, then another t will be taken to come back. So 2t is equals to 7 microsecond. 2t is equals to 7 microsecond. And what is t? T is length divided by Vp. That is equals to 7 microsecond. So let's do it somewhere else. Okay. So 2t is equals to 7 microsecond, right? 2t is equals to 7 microsecond. And what is 2t? 2t is the length that is, what is the time t? What is the time t? So to cover this length L with the speed Vp, how much time it will be taking? That is the time t. So L by distance upon speed, L by Vp. So L by Vp is equals to 7 microsecond, 7 into 10 to the power minus 6. So what is the value of Vp here? Vp is C by under root epsilon r. So C is 3 into 10 to the power 8. What is the value of under root epsilon r? That is 9. So under root 9 will be 3. So your Vp is 10 to the power 8. So 2L divided by 10 to the power 8 is equals to 7 into 10 to the power minus 6. So L is equals to 3.5 centimeter. Because if this goes here, 10 to the power minus 2 and 3.5. Yeah. So length is equals to 3.5 centimeter. So this is also done. Very easy question. Just you need to use the data and solve these kind of problems. So these kind of questions are very easy. The reflection coefficient of a 500 meter line has a phase angle of minus 150 degree. Operating wavelength is 150 meter. Okay, the length of the line is mentioned, that is 500 meter, and operating wavelength is mentioned. How many numbers of voltage maxima you will get there? Okay, phase angle is minus 150 degree. Okay, then let's solve it. How we will solve? So this is the question based on standing wave pattern. If nothing clicks to you in standing wave pattern, then simply write down the expression which we already know. A to the power gamma y plus, this is a lossless line, so I can write down j beta y. So from here we start the solving problems of a standing wave pattern. So this should be your first thing that should come into your mind, that sir, if I know nothing, then at least I know this thing in standing wave pattern. Okay. Now from here I take common. Then what do I get? 1 plus gamma L e to the power minus j2 beta y. Now what is given? The reflection coefficient magnitude is not given. Now if I calculate only VSY, mode of VSY, so that would be V0 plus. Here magnitude is not given, but the phase is given. What is that phase? That is minus 150 degree, and into e to the power minus 2j beta y. Okay, so that phase is given now. 1 plus mode of gamma L e to the power minus j 2 beta y plus 150 degree. So this is the phase we are having. Now we need to, what we need to do, first we will find the location of voltage maxima. We will find the location of voltage maxima. If we know the location of voltage maxima, first if I know the first location of voltage maxima, then I would know the second, third and everything, right? So what will be my first voltage maxima? So for that what I need to do, that my 2 beta y plus 150 degree should be equals to 2n pi, right? So n equals to 0 will not be accepted. Here from here only I can see it, because if I put 2 beta y is equals to 2n pi is 2 pi is 360 degree into n minus 150 degree. So if I put n equals to 0, then y value will be negative. So n equals to 0 is not accepted. So what I need to put, n equals to 1 I need to put. So if I put n equals to 1, so here it would be 4 pi by lambda into y maximum. So n equals to 1 I am putting. If I put n equals to 1, then it would be 210 degree. Okay. So what will be y max? That would be 210 degree into lambda divided by 4 into 180 degree. That would be 210 divided by 4 divided by 180. 0.29166 we are getting into lambda. What is the value of lambda here? Lambda is 150 meter into 150. So 150 also I will do here, because lambda is mentioned, no, wavelength is mentioned. So 150 I will do into 150. So that I am getting 43.75. So in these kind of problems, always you need to calculate the exact values. So 43.75 meter. So your first voltage maxima is occurring at 43.75 meter. And here you can see that gamma L is negative angle minus 150 degree. So on Smith chart you would know that it would be somewhere here. So certainly it has to be capacitive load. If it is a capacitive load, so first voltage minima will occur, and from here as well you can get to know that where will be your minima. Minima will be at 43.75 plus minus lambda by 4. So first you will check for minus lambda by 4, and when I check for minus lambda by 4, I will get to know that what is my minus lambda by 4. Minus lambda by 4 is 150 by 4. 150 by 4 is 75 by 2, that is 37.5. So minus 37.5 if I do, so that is 6.25. So at 6.25 already I am getting minima. But that is of no use here. What is the thing is that first maxima will be occurring at 43.75 meter. The next will be occurring at 43.75 plus lambda by 2. Next will be occurring at 43.75 plus lambda. In that manner it will be occurring, right? And what is the value of lambda? 150. So in that manner it will be occurring. So first one is at 43.75. Then 43.75 plus 75, that would be 118.75. So in that manner we will go, right? So now how much length you are having? You are having a length of 500 meter. You are having a length of 500 meter. So in 500 meter, now 118.75 till 118.75 you are having two maximas. Till this point you are having two maximas. Now how much length is left? 118.75 minus 500. So how much length is left? After that you are having, here you are having your 500 meter. So this much length that is left is 38.15 meter. Now in this 38.15 meter, at every 75 meter, if you start from here, at every 75 meter you are having one maxima. So what I can do is that 31.85 divided by 75 I can do, the number of more maxima I will get. So what I am doing, 38.25 divided by 75. Oh, divided by 75 I need to do. So divided by 75. So more 5 maxima I will get here. In this point, look, either I could have calculated 118.75, then again I would have added lambda by 2. In that manner I could have done the calculation. But smartly if I need to do, so I know that what I have found out, that first minima, then maxima, then again maxima. So this location I have found out. Now next maxima will be occurring after lambda by 2 here, no? Right? The next maxima will be occurring after lambda by 2. So in every lambda by 2, there will be maximas. And what is lambda by 2? That is 75 meter. So after every 75 meter, I will be getting my maximas. So in this length, 38.1, 381.25 divided by 75. What I am getting? 5.08. So in this much of length, I am getting 5 maximas. So 5 maxima and these 2 maxima, total combined is 7 maximas. So this is the answer. 7 maximas. This is the answer. So total 7 maximas you will be getting. Is that clear to you? Easy question. Okay, so on the length there will be 7 maximas. You solve it on your own. I will take a break and then we will restart. This is a very easy question. You can solve it. Certainly you can solve. Yeah, so let's solve this question. You need to tell that which of the following S matrix is representing a lossless network. So for lossless network, what we have studied, that you take any row and take the magnitude of all the S parameters of that particular row, just add them up, it should be equals to 1. Take the second row, take the magnitudes, add them up, it should be equals to 1. So if I do here, what is the magnitude here? 1. 1 square plus what is the magnitude here? This is the angle, magnitude is 1 only. So magnitude is 1 square. 1 square plus 1 square 2. I don't even need to check the second one because in first row only I got to know that this is not lossless. Here 0 square plus 1 square. Yes, this could be lossless, but if I check the second line, then 1 square plus 1 square. Here it is 1 square plus 1 square. What I am getting? 2. So this is also not the possible answer. What about this? 0 square plus 1 square is equals to 1. And here 1 square plus 0 square is equals to 1. So in both of the rows you are getting 1, 1. So correct. What about this? 1 square plus 0 square is equals to 1. But if I check here, that is 1 square plus 1 square. What I am getting? 2. Not correct. Okay. So C option is correct. Very easy. Now this is a new kind of problem for you. You might not be able to solve it. And one more term is there. The device is reciprocal and symmetric. So for reciprocal, I have already told. For reciprocal, if the network is your reciprocal, then S is equals to S transpose. Let's understand it more. What is your S? S11, S12, S21, S22. And what could be your S transpose? That would be S11, S12, S21 and S22. If both of them need to be equal, that means S12 has to be equals to S21, right? So if S12 is equals to S21, then certainly the matrix is reciprocal. And for symmetric, what is the condition? That S11 is equals to S22. So this is the condition for reciprocal. This we have already studied, but this is the condition for symmetric, that all the reflection coefficients should be equal. Okay, S11 should be equals to S22, should be equals to S33, should be equals to S44. So all the reflection coefficients should be equal. So this is the condition. Okay. Now, what they are saying? You need to find the values of mode of S11, S12, S21 and S22. That means if S12 is equals to S21, because the device is reciprocal and symmetric, that means if S12 is equals to S21, that means certainly S12 is equals to mode of S12 and mode of S11 is equals to mode of S22. So I just need to find mode of S11 and mode of S12. Then these values will be by default same only, right? So what I need to find? Mode of S11 and mode of S12. So how will I find mode of S11? What is your S11? Reflection coefficient. What is given? VSWR is given. So what is given? VSWR. What is VSWR? VSWR is given is equals to 2. So if I find reflection coefficient, what that would be? S minus 1 upon S plus 1. So 2 minus 1 upon 2 plus 1. So what is reflection coefficient? 1 by 3. But this is the mode of reflection coefficient. So you are finding mode of S11 and that is equals to mode of S22. There you go. Now what is the next statement shows? What next statement shows is that what they are saying, a 5 dB attenuator. What does that mean? That this network, this two-port network whose S parameters are defined, S11, S12, S21 and S22, this is working as a 5 dB attenuator. This is 5 dB power attenuator should be written, or by default you will take it power attenuator only. What do I mean by power attenuator? That means now when we calculate S parameters, what do? We connect a transmission line here. We connect a transmission line here as well. Then we send some V1 plus at this node. If I am sending some V1 plus, so if I send some V1 plus here, then some part will be reflected back, that would be known as V1 minus, and some part will be transmitted. Now what will be the power associated with this transmitted part? That would be V2 minus square divided by 2Z0. And what will be the power associated with the incident? This was your incident, this was your reflected, and this was your transmitted. So what this device is doing? This device is taking V1 plus, how much power it is taking? V1 plus square divided by 2Z0. So this device is taking V1 plus square by 2Z0 power. Some power it is reflecting back and some power it is transmitting. So that means certainly the transmitted power will be lesser than the incident power. So that attenuation is given by 5 dB. What do I mean by that is that this I am calling as power transmitted, and this is your power incident. Okay, so tan log tan power transmitted divided by power incident is equals to minus 5 dB. This is what is given. Because whenever you take power, always you put 10 here, and whenever you take voltages, you put 20. So whenever I take power, I will put 10 here. So what is given? That power transmitted divided by power incident, and tan log tan of that is equals to minus 5 dB. That means this much attenuation is there. This much part is reflected back, this much part is transmitted. So this much attenuation is there. Okay, so this is being mentioned there. Are you getting this point? So this we need to solve. So if I put tan log tan, the power associated with this transmitted one is V2 minus square divided by 2Z0. So I can put V2 minus square only, because divided by 2Z0 here what I am going to put V1 plus square divided by 2Z0. So 2Z0 will be getting cancelled, and that is equals to minus 5 dB. So from here if I calculate the magnitude of V2 minus divided by V1 plus, what I will get? V2 minus divided by V1 plus, what I am getting? So 20 will go there, so 5 by 20, what I will be getting is that this 2, this is square only, so this 2 goes there, so 5 by 20 plus minus 10 to the power, so 0.56 I am getting. This 0.56 I am getting, and that is equals to what you are getting? 0.56. So from here you have got 0.56. So now this ratio S12 mod, this ratio which is coming out to be V2 minus upon V1 plus, what this is equals to? Mod of S21, and mod of S21 is equals to mod of S12. Why is that so? Because this is symmetric and reciprocal network, right? This is already given, and that is coming out to be 0.56. So this is the answer, that's it. So 0.56 here and 1 by 3 there. So these are the answers. This is the answer and this is the answer. These two are the answers, 1 by 3 and 0.56. Is that clear to you? So this is how we can solve this problem, and new term we got to know, that is a power attenuator. Power attenuator. Now this is the end of assignment, but one important discussion I need to do with you guys. Okay, one more discussion I need to do, and one question on Smith chart also I can think of. Like I need to frame a question on lossy Smith chart, like not Smith chart for lossless lossy will be same, lossy VSWR circle. So I need to frame a question on lossy VSWR circle. So I will try framing a question on lossy VSWR circle, and then we can proceed. And one more discussion I need to do regarding our derivation. So all the derivation we will do with respect to x now. We have done the derivation with respect to y. So with respect to x as well, we will do the derivation. In the beginning, we did not do the derivation with respect to x because I did not want to get you confused. Because if we do the derivation with respect to x as well and y as well, you will be getting confused. So better at that time I only took y. Now I will introduce x as well. Now you will be able to understand the derivations. But that is also important. With respect to x also, the derivation is important, because who knows, they can ask some expressions. So that derivation we will do, and from that derivation we will conclude something. Okay. And one question on Smith chart we can solve, and one question on scattering parameter also we can solve. So in this video only, since this is less than 1 hour of video only, So in this video only that discussion I will add up. So with that discussion, your chapter will be completed. So one more discussion I need to do. So that will take roughly around 1 hour. So that after that discussion, your transmission line chapter will be completed. Okay. Thank you very much. Hi everyone. So continuing this video, so we have seen the assignment. We have studied the complete transmission line. We have studied everything. We started with transmission line equations, then we studied about impedances, then we studied about standing wave pattern, then power calculation, transients, scattering parameters, and Smith chart. So we have studied every single thing. Now let's get back to the first lecture again and derive the equations once again. But now we are going to derive it with respect to x. Okay. So this is my transmission line, which is having ZL load, and this is the source. So just as I close the switch, what will be generated here? V0 plus will be generated. So this is your x equals to 0, this is your x equals to L. Till now what we were studying, y equals to 0, y equals to L, right? If V0 plus is generated, then how will I write my Vx? Vx I will write as V0 plus is generated, then it will travel down with respect to x. So now it is going into positive x direction, right? It is going into positive x direction. So V0 plus e to the power minus gamma x. And then some reflected wave would be coming, that would be plus gamma x. Are you getting this point? V0 plus is walking down in the plus positive x. This would be your plus x, this would be your plus x, and this would be your, this direction would be your plus y. Right? Now can you tell me one thing, what is the value of x plus y? X plus y. Here x plus y is equals to x plus y is equals to L here. Why is that so? Because let's just say if I say that I have covered x distance from here to here, that means I have covered y distance from the load. If I am saying that I have covered x distance from the source side, that means I have covered y distance from the load side, right? From the load side I am covering y distance, from the source side I am covering x distance. So x plus y is equals to L. So what is your x? X is equals to L minus y. So can I replace x equals to L minus y here? What I am gonna do, x equals to L minus y I am gonna replace. So this is what I will be getting, x equals to L minus y. If I replace x equals to L minus y, in place of x, if I replace L minus y. So this will be the Vy equation. What will be the Vy equation? V0 plus e to the power minus gamma L e to the power plus gamma y, V0 minus e to the power gamma L e to the power minus gamma y. So this will be the Vy equation you will be getting. But what is the Vy equation that we studied? We studied this equation. V0 plus e to the power plus gamma y plus V0 minus e to the power minus gamma y. Let me turn on the charger one. Okay, just 1 second. Okay, so this was the equation that we studied, right? Now tell me one thing, what is the difference here? The difference is about this minus gamma L and plus gamma L. Now in this equation, if I say this is my Vy, what is my Vy? If I say this is my Vy, that V0 plus e to the power gamma L plus V0 minus e to the power minus gamma L. And what I am saying, just as I close the switch, V0 plus is generated. Just I close the switch, V0 plus is generated. So if someone will ask me, not gamma L, sorry, it was gamma y. Gamma y. It was gamma y. Now if someone asks me, sir, what is the value at y equals to L? If you put y equals to L here, what you are going to get? V0 plus e to the power gamma L. But what I am saying, that just as you close the switch, V0 plus is generated. But actually what is generated? V0 plus e to the power gamma L. Because if you put y equals to L, what you are getting? If you put y equals to L in this equation, what you are getting? V0 plus e to the power gamma L. But what I was saying, that just as I close the switch, V0 plus is generated. So at that time, some student would be having this doubt. That sir, what you are saying V0 plus is generated, but if I put y equals to L here, because at source end you are having y equals to L. So if I put y equals to L, then this is generated here. So there is something wrong in the equation. No, that is not wrong. What I mean to say is that my V0 plus itself was V0 plus e to the power gamma L. When I was writing this as V0 plus, I was assuming my V0 plus itself was V0 plus e to the power gamma L. Then sir, when you studied bounce diagram, so at that bounce diagram you used your V0 plus here. When you were studying bounce diagram, sir, you used V0 plus here. V0 plus gamma L, V0 plus gamma L, gamma G, V0 plus. So when I was using V0 plus, at that time I was not using y at all. In bounce diagram, was there any use of y or x? No. What we were saying, V0 plus is generated, gamma L, V0 plus, gamma L, gamma G, V0 plus. In that manner we were doing. So in bounce diagram, we did not even use x or y. Are you getting this point, what I am saying? Now you might be thinking that, sir, all the derivation that we did, we found reflection coefficient, we found zy, we found vy, we found iy, all should be wrong. All were derived with respect to this equation. But now I will derive everything with respect to this equation. Still I will get the same expression. You just see it, okay? Just because of this doubt that, sir, at y equals to L, we can get this thing, but you are saying V naught plus is generated. Just because of this doubt, I need to do every single thing, like I need to do this discussion, okay? Because this doubt some student would be having. So now what I am doing is that I am deriving the equation with respect to y again, but what I am doing now, I started with this one, that at just as I close the switch, V naught plus is generated here. At x equals to 0, V naught plus is generated, or I can say at y equals to L, V naught plus is generated. So if it travels down along the x, then this is the equation, that V naught plus e to the power minus gamma x, and then V naught minus will be generated. So with respect to that, you will write down V naught minus e to the power plus gamma x. Right? If this is V naught plus, then this would be V naught minus. So this V naught plus traveled down and it reached here. How it reached here? V naught plus e to the power minus gamma L it will become. Here it will become V naught plus e to the power minus gamma L. Now it will be reflected back minus gamma L. Minus gamma L. Now it will be reflected back. So now what it will be called as V naught minus e to the power plus gamma L. Once it is reflected back, then it will travel down, because if you put y equals to L here, if you put x equals to L here, what you are getting? V naught minus e to the power gamma L. So if you put x equals to L here, this is what you are getting. So here you are having V naught minus e to the power gamma L. Now if it travels down, it would become V naught minus. This is what is happening. V naught plus was generated, then it reached to the load end, it became V naught plus e to the power minus gamma L. Then after the reflection, this wave was V naught minus e to the power plus gamma L. Now if this wave is traveling and if it is again reaching to the source end, this wave has become V naught minus. Is that clear to you? This is what is happening here. And when I write down in terms of y, this is the equation I am getting. V naught plus e to the power minus gamma L e to the power gamma y plus V naught minus e to the power gamma L e to the power minus gamma y. But this is what we studied. Now you are thinking that, sir, all the derivation would go wrong. No, all the derivation will not go wrong. Let's check that out. Okay. So what I am gonna do is that now similarly I can get my iy. Iy would be V naught plus divided by Z naught, and here V naught minus divided by Z naught, because you know the definition of Z naught. What is Z naught? V naught plus divided by I naught plus. That is your Z naught. So from there you can get this equation. Now what I am gonna do? I am gonna put y equals to 0. So at y equals to 0, what you are having? VL and IL. At y equals to 0, you are having VL and IL. So this is what I am putting. At y equals to 0, my Vy would be VL and Iy would be IL. So if I put a VL here, so what I am getting? VL, V naught plus e to the power minus gamma L plus V naught minus e to the power gamma L. Because what I need to put? Y equals to 0. So what I have put? Y equals to 0 I have put. So this term will be gone, this term will be gone. Because these two terms will become 1. Same goes for Iy. I will get IL, and then this Z naught will be multiplied here. IL Z naught, V naught plus e to the power minus gamma L, V naught minus e to the power minus gamma L. Now if I add both of the equation, then I will get this expression. VL plus IL Z naught by 2, V naught plus e to the power minus gamma L. If I subtract both of the equation, then I will get this expression. So these are equation 3 and 4. Is that clear to you? Just simple mathematics. I am not doing it on my own here, because it will just waste your time. All these derivation we have already seen. So this is just simple mathematics. Now what I am gonna do is that I am gonna put V naught plus e to the power minus gamma L at this place, and V naught minus e to the power gamma L at this place. Then what equation I will be getting? This equation I will be getting. And when I solve this kind of equation, what was our Vy? Our Vy was initially when we derived our expression. This was our Vy. This was our Vy. Then what did we do? We put y equals to 0. When we put y equals to 0, our Vy became, when we put y equals to 0, our Vy at y equals to 0 became VL. So our VL would be V naught plus V naught minus. Similarly, IL Z naught would become V naught plus minus V naught plus. Okay, sorry, minus V naught minus. And when I solve both of them, what will be the value of V naught plus? We were getting VL plus IL Z naught by 2. So this was the derivation that we have already done. VL plus I naught IL Z naught by 2. And what about V naught minus? So V naught minus we would be getting VL minus IL Z naught by 2. So this derivation has been already done. So if I put my V naught plus value here, V naught plus value I would be putting here, then I would be getting this equation only, no? I was getting the same equation in lecture 1. In lecture 1 we were getting the same equation. Vy is equals to VL plus IL Z naught by 2 e to the power gamma y plus VL minus IL Z naught e to the power minus gamma y. And when you solve them, this is the Vy equation you get. And at that time as well, the same Vy equation we were getting, and the same Iy equation we were getting. Say yes or no. In the first lecture, you got the same Vy equation and same Iy equation. Do you agree to this point? In the first lecture, same Vy and same Iy, and we were using these equations in our steady state analysis. What did I say? That when I check at steady state, what I'm going to do is that I'm going to replace my transmission line with Z in, and then I will do the steady state analysis. So in steady state analysis, we are using this equation only. So whether you use this equation or you use this equation, using both of the equation, you are getting the same expression of Vy and Iy. So that e to the power gamma L, this e to the power minus gamma L and e to the power plus gamma L is not significant. It is not coming anywhere. Now we will do everything. We will do the analysis of standing wave pattern as well. We will find reflection coefficient as well. You will find that you will see that every expression is same only. Okay. So till now Vy and Iy we have derived, and we see that the same expression we are getting. Now what about Zy? If Vy is same, if Iy is same, then certainly Zy will also be same. So this was our Zy. So Zy is also same. So this particular analysis we already did, and using this analysis we were getting our Vy and Iy, and using this analysis we are getting our Vy and Iy, both are same only. Are you getting this point? Why both are same? Again, I have done the analysis as well. Now let's talk about reflection coefficient. So what would be the reflection coefficient? So if this is my Vy equation, then what would be the reflection coefficient? This is your reflected wave and this is your incident wave. So just a ratio of both of them. So now your gamma y is coming as V0 minus divided by V0 plus e to the power minus 2 gamma y. In our case, what was our gamma y? In our case, our gamma y was V0 minus e to the power minus gamma y divided by V0 plus e to the power gamma y. So what I was getting? V0 minus divided by V0 plus e to the power 2 gamma y. Now what did I call this one? I call this one as gamma L. This was our gamma L. This was the reflection coefficient at load, because if you put y equals to 0, what you are getting? V0 minus divided by V0 plus. So this was our reflection coefficient at load. This I was calling as gamma L. Now here, what is the reflection coefficient at load? So for reflection coefficient at load, what I need to do? I need to put y equals to 0. If I put y equals to 0, so this is what I am getting, V0 minus divided by V0 plus e to the power 2 gamma L. What is V0 plus here? VL plus IL Z0 e to the power gamma L. And what is V0 minus? VL minus IL Z0 by 2 e to the power minus gamma L. This is your V0 plus and V0 minus. In our case, what was our V0 plus and V0 minus? This was our V0 plus and V0 minus. In our case, there was no term of e to the power gamma L. Whether plus gamma L or minus gamma L, there was no term. I did not even introduce, because that would create needless confusion. Now here, what is the ratio of V0 minus divided by V0 plus? This is the ratio of V0 minus divided by V0 plus. And once you put it here, once you put this expression here, what you are getting? Your gamma L is equals to ZL minus Z0 upon ZL plus Z0. This line you cannot see. This I will take down. So what I am putting is that in gamma L I am putting this ratio V0 minus divided by V0 plus. So that is VL minus IL Z0 upon VL plus IL Z0 e to the power minus 2 gamma L into e to the power plus 2 gamma L. So this and this will become 1. So gamma L is ZL minus Z0 upon ZL plus Z0. So this is the gamma y expression you are getting. What expression you are getting? Gamma y is equals to gamma L e to the power minus 2 gamma y. Gamma y is equals to gamma L. This is your gamma L e to the power minus 2 gamma y, where gamma L is equals to ZL minus Z0 upon ZL plus Z0. Were we getting the same expression? Yes. What was our gamma L? Our gamma L was ZL minus Z0 upon ZL plus Z0. And what was our gamma y? Our gamma y was gamma L e to the power minus 2 gamma y only. But that derivation was much easier than this one. Here we needlessly we need to carry this term. Needlessly we are carrying this term. In our analysis, what I did was, I was assuming that at load I am having V0 plus, and at load V0 minus is being reflected. But what is generated in our analysis? In our analysis, V0 plus e to the power gamma L was generated. Because what was our equation? Our equation was V0 plus e to the power gamma y plus V0 minus e to the power minus gamma y. If you put y, what was this? This was your y equals to L, and this was your y equals to 0. If you put y equals to L, what you are getting? If you put y equals to L in this equation, what you are getting? V0 plus e to the power gamma y. So yes, if you put y equals to L in this equation, what you are getting? V0 plus e to the power gamma L. That means at source and V0 plus e to the power gamma L should be generated. Yes. Then it traveled down the distance L, it became V0 plus. Now after the reflection, it became V0 minus, and when it reaches here, it would become V0 minus e to the power minus gamma L. So if you put y equals to L here, what you are getting? V0 minus e to the power minus gamma L only. So this is what we considered. So in our analysis, if I am saying that this is my Vy, if I am saying that this is my Vy, then I will have to say that just as the switch is closed, then V0 plus e to the power gamma L is generated. This is what I will have to say. If I am saying that just as I close the switch, then V0 plus is generated, then this would be the equation. But all our analysis went correct, because even if you use this equation or you use this equation, the same expression you are getting, the same expression of Zy you are getting, same expression of Iy you are getting, same expression of Iy, Vy, Zy you are getting, same expression of gamma y you are getting. Now you will be having the confusion in standing wave pattern, that sir, will the standing wave pattern will also be correct? Yes, standing wave pattern will also be correct, and this what we were calling, this we were calling as gamma L, and that came out to be ZL minus Z0 upon ZL plus Z0 only. So we are just comparing both of the analysis now. Now we will see the analysis of standing wave pattern. So in standing wave pattern, using this equation, this is what I would have written, and using our equation, what I was writing, V0 plus e to the power gamma y plus V0 minus e to the power minus gamma y. Then what I was doing, I was taking this thing as common, 1 plus V0 minus divided by V0 plus, then e to the power minus 2 gamma y I was getting. Okay. Now what was this? V0 minus divided by V0 plus, that was gamma L only. So our equation was becoming, our Vy was becoming V0 plus e to the power gamma y into 1 plus gamma L e to the power minus 2 gamma y. This is what we were getting, right? Now the same thing we are getting here as well. Here what is becoming common? V0 plus e to the power minus gamma L e to the power gamma y into 1 plus this expression. Now can you tell me what is this? This is your gamma L only. Here you can check what is this thing. This is your gamma L. So this particular expression is your gamma L only. So this particular expression is gamma L. So what you have written? Some V0 plus e to the power something into 1 plus gamma L e to the power minus 2 gamma y. And if you take the magnitude, if you take the magnitude on both of the sides, then what you will be left with? Now what will be the magnitude of this thing? I am considering lossless line now. I am considering lossless line. So e to the power minus gamma L will be replaced with j beta. So what will be the magnitude of this one? V0 plus only, because this is phase, this is also phase, so it will be V0 plus only, and this term will come as it is, 1 plus gamma L e to the power minus 2j beta y. Here also I would have got V0 plus into 1 plus gamma L e to the power minus 2 gamma y. So same analysis we used to do, and the same equation we would be getting, if you remember the analysis, right? If you remember our analysis, in our analysis we were getting the same equation. This is what we used to do. First we used to write down Vy, then we used to take this as common, then 1 plus gamma L e to the power minus 2 gamma y. So then we used to take the magnitude. So how we used to take the magnitude? When we take the magnitude, so V0 plus into 1 plus, what about gamma L? In gamma L, mode of gamma L e to the power, here the angle would be e to the power j theta, and this would be minus 2j beta y. So the same analysis we used to do, and then we used to put theta minus 2 beta y equals to 2n pi and n pi. So again the same expression we are getting. With respect to this expression we used to do our analysis. So again there is no difference. In bounce diagram there was no use of y or x, anything. So in bounce diagram what did I say? That just as I close the switch, V0 plus is generated. No issue there, because in bounce diagram V0 plus gamma L V0 gamma L gamma G V0 gamma L square gamma G V0. So there was no use of the distance x equals to 0 or x equals to L or y equals to L or y equals to 0. There was no use of the distance. So if you are doing the bounce diagram, you just need to think that V0 plus is generated and then solve the problem. Even if you think that V0 plus e to the power gamma L is generated or e to the power minus gamma L is generated, still it would give you the same results. What I am saying, even if you say that if the switch is closed and V0 plus e to the power minus gamma L is generated, still it would give you the same result. What will happen? E to the power minus gamma L needlessly will come here. All these things will come needlessly, but eventually V0, this would be cancelling up. Okay, eventually this would be cancelling up. So there will be no use of this one. Are you getting this point? Okay, so needlessly our derivation would become complex. That's why I avoided using gamma L there. But someone would have this doubt. Which doubt? That sir, if you put y equals to 0 here, sorry, if you put y equals to L here, that means you are generating V0 plus at source end. If you are putting y equals to L here, that means you are generating V0 plus e to the power gamma L at source end. But actually, this is what not is being generated. You are saying that V0 plus is generated. So if V0 plus is generated, then this would be the actual equation. But when we do the derivation, we get to know that we are getting the same expression regarding reflection coefficient as well, regarding the standing wave pattern as well, we are getting the same expression. Exactly ditto same analysis we are getting. So whatever that we have studied, that is not wrong. That is derived with respect to this thing only. That we are assuming that V naught plus e to the power gamma L is generated. That will travel down and it will become V naught plus. So that's why I wrote this equation. Okay. And when reflected, it would become V naught minus, and if it travel down, it becomes V naught minus e to the power minus gamma L. So that's why I wrote these equations. And with respect to that equation, I did all the analysis. Now we are just verifying that whatever that we have done, that was correct only. There was nothing wrong. Okay. And then bounce diagram, we did not even use any X or Y. When we were doing the power calculation, if you remember, I asked you that what will be your VA? What will be your, not VA, sorry, what will be your PA? That means from here, if V naught plus is generated, then how much power will reach till the load? What did I write there? That your PA would be, what is the power that is generated? V naught plus square divided by 2Z naught. And how much power will reach at the load? So at that time, what did I write? E to the power minus 2 alpha x I wrote there, because I was assuming that it is covering the distance x in this direction. So at that time I took x. I did not take y there. At that time I took x. So if you are saying that just as you close the switch, then V naught plus is generated, then you should do the analysis with respect to x. But when we study transmission line, always we do the analysis with respect to load. When we studied Smith chart, we were doing the analysis with respect to load. When we were studying standing wave pattern, we were doing the analysis with respect to load. When we were studying about input impedance, when we were studying about any impedance, we were doing the analysis with respect to load only. So in transmission line, all the analysis are done with respect to load only. Only the power calculation is done with respect to this x, okay, with respect to source. So for power calculation, I took x, not y. That V naught plus is generated and it will travel down and it will lose its amplitude y e to the power minus 2 alpha x. And what about cos theta? So cos theta z naught will come, that is coming because of this z naught. So this is what we wrote as PA. Do you remember this point? So every single thing, every single derivation is coming as it is whatever that we have studied. Just the way was different. Okay. So this was our power calculation. So now we have covered every single topic, and I hope you are comfortable now that whether this expression you are using or any other expression you are using, you are getting the same response. You are getting the same expression. So whatever the analysis you have done, in the same manner you need to do the analysis. Just keep one thing in mind, that if we are writing this expression, that if this is our Vy, that means we are assuming that here V naught plus e to the power gamma L is generated. Okay. But whenever you make the bounce diagram, you always assume V naught plus. Whenever you do the power calculation, you always assume V naught plus only, and you assume that this will travel down to the load. And when you get this, whenever you use this Vy equation, Iy equation, you know that whether you assume V naught plus there or whether you assume V naught plus e to the power minus gamma L, always you will get the same expression, because this Vy and Iy and Zy we were getting the same, ditto same. Gamma y also we were getting the same. Here gamma y, what gamma y is becoming gamma L e to the power minus 2 gamma y. So same expression we were getting. So all the expression was same. So this was the important discussion that I wanted to do, because some people in the first lecture would be having this doubt that sir, at y equals to 0, because I received this doubt that at y equals to 0, sir, you are saying that we are generating V naught plus, but if at y equals to L, you are saying that sir, we are generating V naught plus, but if we put here, we are getting V naught plus e to the power gamma L. So what is the reason behind that? So the reason is that our V naught plus was something else. Is that clear to you? All okay? All done? Yeah. So this was the conclusion of everything that we have studied. Now we will solve few problems. So this is the question given in front of you. You need to write V2 plus in terms of V1 plus gamma and L, and you need to write V0 plus in terms of V3 plus gamma and L. So try doing it on your own. I will take a break and then I will come back. So you need to write these expressions. Okay. Yeah. So let's start this question. So whenever I see these kind of questions, what I will see that this V1 plus is traveling. Now it will travel down the distance L and it will become V2 plus. So from where to where it is traveling? It is starting from here and then it is going in this direction. So I will always do the analysis with respect to this, that this I will assume x and this I will assume at x equals to L. Why I am doing the analysis from x equals to 0 to x equals to L? Later on I will convert that y equals to 0 is there, y equals to L is there. This is given in the question. Later on I can convert x into y. The same thing we did here. What we did here, first we assumed that V0 plus was generated here. V0 plus was generated here. So with respect to V0 plus, I did the analysis that V0 plus will travel down and it will become V0 plus e to the power minus gamma x. Then I converted x into y. So same thing I will do, that from this particular side, V0 plus is generated. Now it will travel down. So in which direction it is going? in this direction it is going. So I will assume x equals to 0 here and x equals to L here. So if I write down the equation, if I write down the v1y equation, v1x equation, what I am writing, v1x equation. So what that would be? That equation would be that initially it was v1 plus, now it will travel down in positive x direction. It will travel down in positive x direction. So this is how it will travel down, v1 plus e to the power minus gamma x. We have seen this in EM wave as well. If your wave is traveling in positive x direction, so this you are assuming as positive x. This was not given, this you assumed on your own, and this is your positive y. So initially you are having v1 plus magnitude. Now it traveled down to L distance. It became v1 plus e to the power minus gamma x. Okay. It has traveled down any x distance. I am not saying that it has traveled L distance. I am just saying that it has traveled any x distance. Now if I need to write down this equation in terms of y, then what I need to do? Here I can see that x plus y is equals to L. Because y is the distance that is covered from here, x is the distance that is covered from here. So x plus y is equals to L. So if I need to write this equation in terms of y, what I will do? In place of x, I will write L minus y. So what I am getting? v1 plus e to the power minus gamma L e to the power gamma y. So what I am getting? My v1y is v1 plus e to the power minus gamma L e to the power gamma y. So if I write in terms of y, then I will say that here v1 plus is not generated. Here v1 plus e to the power minus gamma L is generated. And at y equals to 0, at y equals to 0, what your v1 is becoming? Your v1 at y equals to 0 is becoming v2 plus. So your v2 plus is equals to v1 plus e to the power minus gamma L, and once you put y equals to 0 here, it would be 1 only. So this is what you are getting, that v2 plus is equals to v1 plus e to the power minus gamma L. But was this analysis required? What I could have done, from here only I could have found it out, no? That v1 at x equals to L. Because with respect to x, you have covered L distance. So v1 at x equals to L, what it would be becoming? v2 plus only. And v2 plus will be equals to v1 plus e to the power minus gamma L only. So here only I could have written the answer. This analysis was not even required, right? But if I need to write down the equation in terms of y, this is how I will be writing it down. Are you getting this point? Why we are studying all this thing? Because sometimes in your questions you need to write down this v2 plus in terms of v1 plus, and obviously in terms of L as well, in terms of x as well. Not only this v2 plus, they can ask any v5 plus here as well, that this v5 plus is generated at some distance L by 2. So what will be your v5 plus in terms of v1 plus, or they can ask what will be your v5 plus in terms of v2 plus. So if I ask you what is your v5 plus in terms of v2 plus, what I am saying, you need to write down your v5 plus in terms of v2 plus, and this v5 plus is generated at some distance L by 2. Try doing it on your own. So what I will say, that sir, v5 plus is traveling, when it travels down a distance of L by 2, it becomes v2 plus. What I am saying is that sir, this v5 plus is traveling, when it travels down a distance of L by 2, it becomes v2 plus. So what will be your v2 plus? So your v2 plus will be, then v5 plus is traveling, when it travels down a distance of L by 2, it becomes v2 plus. So from here it is traveling, when it travels down a distance of L by 2, it becomes v2 plus. So this will be your v2 plus. And if you need to write down v5 plus, so v5 plus will be v2 plus e to the power, this comes here, gamma L by 2. There you go. Same analysis you can do with v1 plus and v2 plus as well. What will be your v2 plus? v2 plus is, when v1 plus travels down a distance of L, it becomes v2 plus. So what is your v2 plus? v2 plus is, when v1 plus travels down a distance of L, it becomes v2 plus, right? So what would be your v1 plus? Your v1 plus will be v2 plus e to the power gamma L. Now what about the relation between v1 plus and v5 plus? So what you will say, when v1 plus travels down the distance of L by 2, it becomes v5 plus. So what will be your v5 plus? Your v5 plus will be, when v1 plus travels down a distance of L by 2, it becomes v5 plus. So this will be your v5 plus. Or you can write down that my v1 plus is equals to v5 plus e to the power gamma L by 2. So anything you can write down. Okay. Now if you put this and this, if you equate both of them using equation, let's just call this as equation 1 and using equation 1 and 2. So 1 and 2, if I equate 1 and 2, what I am getting? That my V2 plus e to the power gamma L is equals to V5 plus e to the power gamma L by 2. So from here what I am getting, that my V5 plus is equals to, if this goes here, what you are getting, V2 plus e to the power gamma L by 2 only. So this is equation, if this I call as equation 4, then equation 4 and 3 are same only, that V5 plus is equals to V2 plus e to the power gamma L by 2, V5 plus is equals to V2 plus e to the power gamma L by 2. So what you have studied, you will see the direction that V1 plus is going in this direction. If it reaches V5 plus, that means it has traveled down a distance of L by 2. And similarly for V5 plus, it has traveled down a distance of L by 2. What about this V3 plus and V4 plus? How you will write it down? So what you will say, that you will get V4 plus, first see the direction of propagation. V3 plus is going in this direction and it has become V4 plus. V3 plus is going in this direction and it has become V4 plus. So what you will say, when V3 plus travels down a distance of L, forget about this Y and X, forget about this Y and X. What you will say, when V3 plus travels down a distance of L, it becomes V4 plus. So what you can write down, that my V4 plus is equals to, when V3 plus travels down a distance of L. That's it. Or you can say that what I need to write, I need to write V4 plus only. So that's it. This is your answer. Or if you need to write down in terms of equations, then how will you write down? Okay. So V3 plus is traveling in which direction? In positive Y direction, right? V3 plus is generated at Y equals to 0 and it is traveling in positive Y direction. So what I can write? That my V3 plus Y. Similarly, here I wrote down V1x. So here I am writing V3y equation. What I am writing? I am writing V3y equation. Here I wrote the equation of V1x because V1 was traveling in positive x. Now V3 plus is traveling in positive y. V3 plus is traveling in positive y. So I can write down V3y equation. What would be V3y? V3y would be V3 plus x e to the power minus gamma y. Why is that so? Because it is traveling in positive y direction. Okay. And now V3 at y equals to L. V3 at y equals to 0. If you put V3 at y equals to 0, what it will be? V3 plus only. So at V3 at y equals to 0 is V3 plus only, right? And if you ask me V3 at y equals to L, what it would be? V3 plus e to the power minus gamma L. Say yes or no. So from, and this is equals to V3 at y equals to L. V3 at y equals to L is equals to V4 plus. So from here what you are getting, that your V4 plus is V3 plus e to the power minus gamma L. So this is just the way I am telling that how you can write down one wave in terms of other wave. Now if I need to express this equation in terms of x, how would I express it? That's our V3x would be equals to V3 plus e to the power minus gamma, and in place of y what I can put? L minus x, because I know that x plus y is equals to L. So y will be L minus x, y will be L minus x. So what I am getting? V3 plus e to the power minus gamma L e to the power gamma x. So this is your V3x equation in terms of x. Now this V3x at x equals to 0, what it will become? V4 plus. This V3x at x equals to 0 will become V4 plus. So if you write down V3 at x equals to 0, what it will become? V4 plus. Are you getting the same expression? Yes. If you put x equals to 0, this will become 1 only. So you are getting the same expression. Say yes or no. What else I could have seen? What else I could have seen is that if you put V3 at x equals to L, at x equals to L, what is your V3? It is equals to V3 plus. At x equals to L, your V3 is equals to V3 plus. So at x equals to L, it will be equals to V3 plus, and that would be equals to, if you put x equals to L here in this particular equation, because this is your equation V3x, if you put x equals to L here, what you are getting? V3 plus e to the power minus gamma L, and if you put x equals to L here, this and this is getting cancelled, that is equals to V3 plus only. Are you getting this point? What I am saying is that this is your V3 equation with respect to x. So if you put x equals to L here, what you are getting? V3 plus e to the power minus gamma L e to the power gamma L. What we are getting equals to V3 plus only. And you know that V3 at x equals to L becomes V3 plus only. So these x and y are very confusing for the students. but these are nothing but the coordinate in the manner that you see, that whether you are seeing with respect to x or with respect to y. So easiest way is see the direction of wave propagation. Here I know the amplitude, that is v1 plus. So if I see the direction of propagation, that is plus x. So what I will write down, v1 plus e to the power minus gamma x. Here if I see the direction of propagation, that is plus y. So what I will write down, v3 plus e to the power minus gamma y. Now I need to check at which distance I am going. If I am reaching at L distance, then I can write down e to the power minus gamma L in the same manner. Okay. Now let's solve this question which was asked in GATE examination. So the S parameter of this particular network is given with respect with the reference of Z node. That means the transmission line which we are connecting, which is of impedance Z node. Now what they are doing? Now they are adding two lossless transmission line section of electrical length theta 1 equals to beta L1 and theta 2 equals to beta L2. They are adding two lossless transmission lines here. Okay, where electrical length is beta L1 and beta L2. What do you mean by electrical length? Electrical length means you are writing down your length with respect to phase. Okay, in terms of phase you are writing down the length. Otherwise I would have written the length is L1. Actual length is L1. If I am writing with respect to phase, then I would write down beta L1. Is that clear to you? Okay. Now what you need to find? You need to find S parameters of the resultant two-port network. That means this is your resultant two-port network. No? You need to find S parameter of this resultant two-port network. So if any network is given, how do we find its S parameter? How do we find its S parameter? What do? We send some V1 plus. Then here V1 minus is reflected, some V2 minus is transmitted, and you send some V2 plus. So V2 minus is reflected and V1 minus is transmitted. So this is what we do, right? And then we find out these ratios and define our equations. Now here these S11, S12 are defined with respect to this thing, that from here you sent V1 plus, then V1 minus would have been reflected. From here you would have sent V2 plus and V2 minus would have been reflected. Now what we need to do, now this is our network, our new network is this one. So now what we will do, we will send some V1 new plus here and V1 new minus will be reflected back, and here we will send some V2 new plus and V2 new minus will be reflected back. V2 new minus will be reflected back. Are you getting this point? What do we know? We know the ratio of V1 minus upon V1 plus, that is S11. We know the ratio of V2 minus upon V1 plus, that is S21. So these ratio we already know. That what we know is that our S11 is V1 plus divided by, S11 is V1 minus divided by V1 plus when V2 plus is 0, right? What is our S12? Our S12 is V1 minus divided by V2 plus when V1 plus is equals to 0. What is our S21? Our S21 is V2 minus divided by V1 plus when V2 plus is equals to 0. And what is our S22? S22 is our V2 minus divided by V2 plus when V1 plus is equals to 0. This we already know. S11, S12, S21, S22 we already know. But we do not know this V1 n plus, V1 n minus, V2 n minus and V2 n plus. So can we write down V1 n plus in terms of V1 plus? Yes. What we will say, V1 n plus will travel down a distance of L2. V1 n plus will travel down a distance of L2 and it will become V1 plus. Say yes or no? V1 n plus will travel down a distance of L2, will travel down a distance of L2, whether it is L2 or L1, it is L1, will travel down a distance of L1 and it will become V1 plus. The same analysis that we studied here, that V1 plus will travel down a distance of L and it will become V2 plus. So same analysis we are doing here, that V1 n plus will travel down a distance of L1 and it will become V1 plus. Since it is a lossless line and the value of beta mentioned is e to the power minus j beta L1 is equals to V1 plus. Okay, so what will be your V1 n plus? that would be V1 plus divided by e to the power minus j beta L1. Is that okay to you? Okay. Can you write down V1 n minus? What you will say that V1 minus will travel down a distance of L1 and it will become V1 n minus. What I am saying, V1 minus will travel a distance of L1 and it will become V1 n minus. Do you agree to this point? V1 minus is traveling a distance of L1 and it is becoming V1 n minus. Same thing. So this is your V1 n minus. This is your V1 n minus. And sorry, here with respect to gamma you need to put j beta. So your V1 n minus is equals to V1 minus e to the power minus j beta L1, right? This is your V1 minus. This is your V1 plus. Okay, just a second. Yeah, so I was thinking only, so this error I was doing, no? So it would be plus e to the power minus j beta L, so it will be plus j beta L, no? This is going here. So it would be V1 plus e to the power plus j beta L. Now same thing you need to do with V2 minus and V2 n minus as well. So what would be your V2 n minus? You will say that, sir, V2 minus travels down the distance of L2, you will get V2 n minus. So what would be your V2 n minus when V2 minus travels at distance of L2, right? This would be your V2 n minus. And what about this V2 n plus? So V2 n plus, if it travels the distance of L2, you get V2 plus. So if V2 n plus travels at distance of L2, you get V2 plus. So what will be your V2 n plus? That would be V2 plus e to the power plus gamma L, or you can say j beta L2. Okay. So this will be your V2 plus. Here j beta they are representing, j beta L1 they are representing by theta 1. So that we will see. So what will be your S11? S11 new. S11 new. That would be equals to V1 n plus divided by, sorry, V1 n minus divided by V1 n plus, right? V1 n minus divided by V1 n plus. V1 n minus divided by V1 n plus. That will be your S11 new. What is your V1 n minus? That is equals to V1 minus e to the power minus j beta L1 divided by V1 plus e to the power plus j beta L1. So what you are getting? V1 minus divided by V1 plus e to the power minus j beta L1 and another minus j beta L1. So j beta L1 is equals to theta 1. Beta L1 is equals to theta 1 they have given. So what you can write? What is V1 minus divided by V1 plus? V1 minus divided by V1 plus is equals to V2 plus. And certainly this condition is coming when your V2 n plus is equals to 0. When V2 n plus is equals to 0. So if V2 n plus is equals to 0, that means certainly V2 plus is also equals to 0. If V2 n plus is equals to 0, then V2 plus is also equals to 0. So if V2 plus is equals to 0, this can be replaced with S11. And beta L1 is equals to theta. So this is 2 theta. So e to the power minus j 2 theta 1. So this is new S11. Are you getting this point? So your S11 new is coming out to be S11 e to the power minus j 2 theta 1. This is your S11 new. Is that clear to you? S11 new. Let's find out other things. What I need to find? S12 new. So what will be S12 new? That would be V1 n minus upon V2 n plus, considering V1 n plus is equals to 0. So what is your V1 n minus? V1 n minus, that is V1 minus e to the power minus j beta, V1 minus e to the power minus j beta L1 divided by, what is your V2 n plus? V2 n plus is V2 plus e to the power j beta L2. V2 plus e to the power j beta L2. J beta L2. Okay. So what I can write? V1 minus divided by V2 plus. So you let me know one thing. If V1 plus is equals to 0, if V1 plus is equals to 0, that means certainly V1 plus is also 0. V1 n plus is 0, that means certainly V1 plus is also equals to 0. So here V1 plus is also equals to 0. And this we are getting minus J beta L1 and J beta L2 also goes upward into minus J beta L2. So beta L1 is theta 1 and beta L2 is theta 2. So what is this guy? What is this quantity? This quantity is S12 e to the power minus J theta 1 plus theta 2. Okay. So this is your S12 nu. E to the power minus J theta 1 plus theta 2. E to the power minus J theta 1 plus theta 2. So in the same manner you can find out other things as well. Shall I need to do it? Since this is a recorded video, so I have to do it. If it was offline class, then I did not need to do it, right? So V2n minus upon V1n plus when V2n plus is equals to 0. So what that would be equals to, what is V2n minus? V2n minus is equals to V2 minus e to the power minus J beta L2. V2 minus e to the power minus J beta L2, right? Beta L2. And what is your V1n plus? That is V1 plus e to the power J beta L1. And if V2n minus is equals to V2n plus is equals to 0, that means certainly your V2 plus is also equals to 0. So e to the power minus J, this is your theta 2 and this is your theta 1. Okay. So what this is equals to S21 e to the power minus J theta 1 plus theta 2. So what you are getting, S21 nu is equals to S21 e to the power minus J theta 1 plus theta 2. So this is your new S21. What about S22? S22 nu will be V2n minus upon V2n plus, considering V1n plus is equals to 0. So that would be equals to V2 minus e to the power minus J beta L2 divided by V2 plus e to the power J beta L2. And when I see it, V2 minus divided by V2 plus, if V1 plus n plus is equals to 0, that means V1 plus is also equals to 0 e to the power minus J beta L1 plus L2, or minus J beta L1 plus L2 can be written as, sorry, L2 is there. So minus 2 J beta L2, so that would be minus J theta 2. Okay. Minus J2 theta 2 it would be, sorry, minus J2 theta 2. So this can be replaced as S22 e to the power minus 2J theta 2. So S22 nu is coming out to be S22 e to the power minus J2 theta 2. Okay. So this is your S22 nu. So which is the option? First option. So this was an easy question only. Just you need to write down V1n plus and V1n plus, V1n plus and V1 plus in each other's terms. So this we have already studied here. Or here also I did this analysis just because there was one doubt, and so that I could teach you this thing. That you can write down these waves in terms of anything. That from here if V0 plus is generated, then what will be reaching here? V0 plus e to the power minus gamma L. And if here V0 minus e to the power gamma L is generated, that means what will be, what I am saying is that I can add a page. What I am saying that if this is the transmission line and you are saying that here V0 plus is generated, here V0 plus is generated. So at the load end what will be reaching? V0 plus e to the power minus gamma L, because it travels a distance of L. Forget about x and y. Forget about x and y. How much distance it is traveling? It is traveling a distance of L. And if you say that here something is generated, I don't know what is generated, here something is generated. So what will be reaching here? Here V something e to the power minus gamma L will be reaching, because this is traveling down a distance of minus gamma L. And now I am saying that this is equals to V0 minus. What I am saying, whatever that is reaching here, that is equals to V0 minus. So what would have started here? Here V0 minus e to the power plus gamma L would have started. Because if V naught minus e to the power minus gamma L travels down the distance of gamma L, then this will be the magnitude. This is the starting point. At starting, you are having this much of wave. Then if it travels down a distance of L, then how it will lose? E to the power minus gamma L it will lose. E to the power minus gamma L it will lose. So if it is losing e to the power minus gamma L, then what will be reaching here? V naught minus. Are you getting this point? What we are doing? So V naught plus was generated here. V naught plus minus e to the power minus gamma L reached here. Now in the reflection, V naught minus e to the power gamma L was generated, and that traveled down and it became V naught minus. So at the load, I could have written my reflection coefficient as, this divided by this. So V naught plus V naught minus divided by, then this I would be getting. But this analysis we are doing in the last lecture. Initially what we did when we were studying. So initially what we did was, we were saying that here V naught plus is generated. What we were saying? Here V naught plus is generated. So what would have started from here? V naught plus e to the power gamma L, say yes or no. If I am saying that here V naught plus is generated, then that means V naught plus e to the power gamma L would have started and it traveled down a distance of L. So what we are getting? V naught plus. And what else I said? That in the reflection, here V naught minus was generated. So if it travels down a distance of L, then what it would become? E to the power minus gamma L. So here what was our reflection coefficient at load? It was V naught plus divided by, V naught minus divided by V naught plus. But both eventually would give us same expressions only. So whatever the analysis that we did, that was absolutely correct. Just the thing is, if I am writing down here, I would have written down my Vy equation as V naught plus e to the power gamma, because what is generated here? V naught plus is generated. And at if this is your y equals to 0 and if this is your y equals to L. So at y equals to 0, I need V naught plus e to the power minus gamma L. So I need to write V naught plus e to the power minus gamma L, gamma y, plus V naught minus e to the power gamma L minus gamma y. But what we took the equation? This equation we took. V naught plus e to the power plus gamma y plus V naught minus e to the power minus gamma y. Because we were assuming that at y equals to 0, we were having V naught plus and V naught minus. And in bounce diagram, we needed V naught plus. When we were studying bounce diagram, what did I say? Just as I close the switch, V naught plus is generated. But at that time, I did not need the distance. And when we were doing the steady state analysis, Vy and Iy. So in both of the cases, you get the same expression of Vy and Iy. If you do this analysis as well, then you get the Vy expression, this only, VL cos hyperbolic gamma y plus IL z naught sin hyperbolic gamma y. And when you do this analysis, then also you get the same expression. So steady state analysis was same for both of them as well. Okay. Just the thing is, in bounce diagram, you started with V naught plus. Is that clear to you? All this analysis is clear to you, every single thing, what I wanted to do. If I had taught all these things, ideally I should have taught all these things in first lecture. But if I had taught all these things, you wouldn't be coming to the last lecture for sure. Because you wouldn't be understanding anything. That's the thing with transmission line. Like we confuse it with this plus minus so much that students don't even understand the required concept. The required concept is understanding standing wave pattern. The required concept is understanding bounce diagram. The required concept is understanding transient analysis, understanding power analysis. At that time, you do not need to think about this plus gamma L minus gamma L. Just whatever that I have told, you think. But you should know along the transmission line how I can write down the equations. Now all the things should be crystal clear to you. I hope you will not find any difficulty in solving any problem of transmission line. Now one small concept is left. One small concept is left. What is that? That concept is lossy Smith chart. So Smith chart will be same for lossy and lossless line, because in Smith chart what we plot ZL dash. So ZL dash will not depend on your transmission line. ZL dash will be applied by the user. But the VSWR circle, in VSWR circle what we do? We walk along the transmission line. Once we walk along the transmission line, then our VSWR circle will change. So that thing we need to see in the next lecture. Till now, till this date, in any competitive examination, even in your semester exam as well, they would have never asked VSWR circle for lossy transmission line. But this is my job. In any day, in any examination, they can ask a question on lossy transmission line as well. So as an educator, I need to teach it. So it would be roughly around 1 hour of video. If you have time, certainly you should watch it. Certainly something new and something very conceptual you will understand. Okay. Yeah. Thank you very much.